4.1, this is a section on exponents. So we have a list of exponent rules which you need to memorize for your test. These rules are also found in your textbook. I have written out 5 of these rules and we're going to go through them and also use them to simplify some examples. Let's take a look at the first rule. It's called the product rule and it's used for multiplication when you have the same base. The base here is A. And what we do when we're multiplying is we add our exponents m and n, you add them and you get a to the m plus n. For division with the same base only, you are going to subtract your exponents, numerator exponent minus denominator exponent. So very quick note, to use the product rule and the quotient rule, you have to have the same base. If we do not have the same base, we do not use these 2 rules. Negative exponent rule, there are 2 possibilities. If you have a negative exponent in the numerator, you can rewrite it so that way you write 1 over a to the positive n, and this makes your exponent positive. If you have a negative exponent in the denominator, we write it as a to the positive m in the numerator. The whole idea of this rule is to just rewrite what you have so that your exponent is positive. And all you have to remember is that if you switch the location from numerator to denominator or denominator to numerator, it automatically changes the sign of the exponent. Power rule. There are 3 possibilities, but essentially we are just multiplying exponents for all of these. To use the power rule, you have to make sure that you have 1 parentheses, 2 exponent on the outside, and 3, you need to have a monomial on the inside of the parentheses. Monomial is 1 term. If you have more than 1 term, you do not use the power rule. So again, you're just going to multiply your exponents, m times n. If you have a division problem, you again multiply, so 1 times n and then 1 times n. We get a to the n over b to the n. And if we have more than 1 variable, the same thing applies, multiply your exponents. The rule for B and C is written in general with an exponent of 1. However, your exponent can be any number. It could be positive, it could be negative, it could be 0, it could be 1, it could be 2, it could be anything. It's just easier to write it with a 1 when we write the rule. And our last rule is our 0 exponent rule. A to the 0 is equal to 1 as long as your base a is not 0. So let's take a look at some examples. What we want to do is simplify and write the final answer with positive exponents. The same directions you'll see for your test. Both A and B have the same base throughout. These are both base x. Let's look at the first example. In the numerator, you have a product, so we should use the product rule. In the denominator, I have a situation that looks like 4a, so we use the power rule and multiply our exponents. So back to the numerator, you add 8 plus negative 2 is going to be x to the 6th. The denominator is also x to the 6th. Now use the quotient rule, subtract your exponents. X to the 0, using the 0 exponent rule, is equal to 1. And we have our final answer. Example 2. Again, there is a product in the numerator and also in the denominator. So we're going to use the product rule twice here. Write your base once. Add your exponents. So 10 plus -3, that's going to give us 7. And write your base once. 3 plus -12, that's going to be -9. Now, since it's division with the same base, we use the quotient rule, but be careful because you need to make sure you do this correctly with the signs. It's going to be 7 minus -9. Because this exponent is negative, the problem now actually turns into an addition with your exponents. So it's really 7 plus 9, and that's going to give us x to the positive 16. And that gives us our final answer for B. And let's take a look at C. So this problem is a little different. This problem, we have parentheses and an exponent on the outside, and you can actually simplify inside the parentheses. Let's start by simplifying inside first. It just makes it a little bit easier. So leave everything on the outside the way it is. Okay, so I'm going to recopy 2 and recopy 3, recopy A. The only thing we could simplify is the part that has the same base. B to the 4th, B squared. You are going to use the quotient rule and subtract your exponents. And the answer you get goes in the numerator. So it's going to be B in the numerator. 4 minus 2 is 2. Once the simplification is complete, then we're going to use power rule part B. And also, it's kind of like B and C together. You have to take -3, multiply it with all the exponents in the numerator and all the exponents in the denominator. Be careful because 2 has an exponent of 1, A has an exponent of 1, and 3 has an exponent of 1. So when we multiply, we can't forget about 2, A, and 3. Even though you can't see the exponent, it's automatically assumed to be 1. So let's see what happens. 2 to the -3, A to the -3, B to the -6, and 3 to the -3. At this point, you have to be careful. This is a place where a lot of students make mistakes. They automatically calculate these two values right here. They calculate what these two are equal to, but you actually do not want to do that. What you do want to do is rewrite the whole problem so all the exponents are positive. You don't want to calculate 2 to the -3 and 3 to the -3 until the exponents are positive. So to do that, we use our negative exponent rule and just change the location of all of these, where the denominator, for example, 3 to the -3 goes to the top. Everything down here moves to the denominator. So now we can calculate. 3 to the 3rd is 27. 2 to the 3rd, that's 8. And that gives us our final answer.